So I had this great video that I just did, but I didn't have record on. So here we go again. The washer method. I want to find the volume of this function, and it's not really in the format that we're used to, but I can do the inverse, right? So if I do inverses of both sides, this is just flipping that function. So basically, if I draw this, hopefully trying to stay on screen, and I'm doing the tangent. Now I'm revolving this around the y-axis, so all I care is about these positive values. So I don't know, something that looks like this. But now this is my pi over 4, and tangent of pi over 4 is what, 1? So what I'm doing here is I'm revolving it around the y-axis, and then I'm doing this washer method where you kind of have that hole inside, right? And so probably not the best drawing in the world, but what I can see is my outer radius is going to be from here to there to 1. My inner radius is going to be from here to my function. So I have my limits of integration are going to be my y, because it says about the y-axis. So from 0 to pi over 4. I have a pi. I could have thrown it out front, but didn't. I have my outer radius, which is 1 squared. Okay, that's from there to there. And then my inner radius, which is to my actual function, which was what? Tangent y squared. Okay, so from here, it would be really nice if I could do something with this. So we kind of remember an identity, maybe, perhaps. Tangent of, let's just use y since that's our variable, plus 1 equals secant squared y. Well, couldn't you solve this for tangent of y by, by chunking the 1 to the other side? So in other words, this becomes my tangent squared becomes secant squared minus 1. So am I still good to go on the board? So I have 0 to pi over 4. Let's go ahead and throw that pi out front because it's just a constant. Just get it out of the way. Of course, I'm going to have 1 minus secant squared y minus 1. I got the right parentheses. And then dy. Okay, so all I did was a little substitution because I know how to find the antiderivative of secant squared. It's tangent, right? So that part's kind of nice. So if I go, say, here, then I have my pi. I have my 0 to pi over 4. I have 1 minus a negative 1. So 1 plus 1, 2. And then minus secant squared y dy. I'm getting close to the end over there. All right, so get out of the way of the writing. And so from here, I do my antiderivative. So 2 is just going to be 2y. And as I said before, the secant squared, remember, is tangent. You remember that, right? Yes. So I have the pi out front. This is my antiderivative. So 2y minus tangent y, and I'm evaluating this from 0 to pi over 4. Alright, so then from here you just start plugging things in. So I got pi, I got 2 times pi over 4 minus tangent of pi over 4. Now really, I run out of room, but remember this is that whole f of b minus f of a. So you really should do the minus f of a, but if I plug in 0, I'm going to get 0 minus 0, and that's just 0, so I ain't going to do it. But you got to be careful, okay, so you should be doing that as well. Now since I've run out of room, I guess we're going to go right chair. Yeah, that'll work. And so I just end up with this pi, and then 2 pi over 4, pi over 2, and then of course minus 1 because the tangent of pi over 4 is 1. And that's pretty much it. I mean, if you want to make it look a little bit better, I don't know that this makes it look better, but I just distribute the pi and you get your answer. And I actually did throw that in a calculator, and I got approximately 1.79 for that area. So again, this is using the washer method. Hopefully it was kind of helpful. I know, bad picture, but the whole idea, hope you got the concept.